Welcome dear students. So in the previous video lecture we discussed about preparation of ammonia, okay, and we discussed about various conditions by which we can increase the production of ammonia by Haber's process, okay. So that was an important question. Today we will discuss properties, okay, properties of ammonia, okay. So physical and chemical properties, okay. So ammonia is a gas highly soluble in water. Its aqueous solution is basic, okay. Basically when ammonia is a gas, when dissolved in water forms ammonium hydroxide aqueous. And ammonium hydroxide is basic, okay. Now we will see some chemical reactions, okay, with different type of salts. Okay, so let's discuss some ammonium hydroxide reactions. It will precipitate different cations to precipitate different cations, like suppose zinc sulfate ammonium sulfate, okay, and in this reaction you will get zinc hydroxide as white precipitate, okay. Similarly FeCl3 when reacts with ammonium hydroxide, okay, it gives ferric hydroxide, Fe2O3, hydrated salt and ammonium chloride, okay. And this is solid, this is brown precipitate, okay, brown precipitate. Okay, now we know that there is a lone pair on ammonia. I have told you about the structure of ammonia earlier, so you guys have basically an idea about how ammonia looks. It's the structure of ammonia. Basically this has a lone pair. So because of the presence of lone pair, ammonia act as a Lewis base, okay, and ammonia form complex with different D block element like copper, okay, and when it reacts with aqueous ammonia, okay, it forms copper, tetraamine copper, 2 positive, okay. This complex will be formed and this is deep blue in color. Okay, deep blue in color. So, and these reactions are very helpful in detecting different elements. Okay, like copper can be detected using this reaction. Okay, because of the blue coloration. Similarly, silver, it's any silver salt in aqueous solution. In aqueous solution gives AgCl solid. That means it's white precipitate. Okay, white precipitate. Now this AgCl2, no, AgCl, yeah, AgCl. This AgCl when reacts with ammonia, aqueous, it will form a complex colorless. Actually, colorless means the precipitate disappears. Okay, so this is a very important reaction. Using this reaction, we detect acid radicals in inorganic chemistry. Suppose you have a how this reaction is used. Suppose we have chloride as a radical. Suppose sodium chloride. So suppose we have sodium chloride. So sodium chloride is first treated with AgNO3. Okay. So what it will give? It will give a precipitate of AgCl and okay. And this precipitate. Okay. This is how we detect chloride. Actually, if we take sulfate, then same white precipitate will appear. This is white. And if sulfate is here, then sulfate precipitate is also white. But the difference is the chloride precipitate will dissolve in aqueous ammonia, okay, which will confirm the presence of chloride ion. But if it is sulfate, then it will not dissolve. Okay, so this is how chloride is detected. The presence of acid radical chloride is detected using this reaction. Okay, the reaction of copper with ammonia is very important. Now we have oxides of nitrogen, but the structure of oxides of nitrogen has been removed from the syllabus. As you all know that 30% of the syllabus has been deducted. So the structure of oxides of nitrogen has been omitted from the syllabus. So we will not do this part. So next we will study nitric acid. Okay, we will study about nitric acid. So first of all, we will see the preparations, how nitric acid is prepared. So laboratory method, lab method is that sodium nitrate or potassium nitrate is treated with sulfuric acid and it gives sodium bisulfate plus nitric acid. So this is laboratory method to prepare nitric acid. Okay, now industrially industrial preparation is done by Ostwald's process. Okay, Ostwald's process. And what we do in Ostwald process? In Ostwald process, ammonia is first oxidized by atmospheric air. Okay, this is atmospheric oxygen. Platinum or RH gauze catalyst. We will need platinum catalyst, 500 kelvins of temperature and 9 atmospheric pressure. Okay, and we will get 4 NO plus 6 H2 gas. Okay, nitric acid thus formed combine the oxygen with. Now this NO is further oxidized giving NO2. Okay, and finally this NO2 is dissolved in water giving HNO3. Okay, NO. You have to balance this reaction. So liquid, gas, aqueous and NO gas. Now this NO gas will be further used here. Okay, oxidized to NO2, and then NO2 will be again dissolved in water and so on. Okay, so NO is thus recycled. Okay, now using this method, after distillation we can get concentrated nitric acid from this reaction. Okay, now we will we have to study about the properties of nitric acid. So there are various reactions of nitric acid. Okay, physically it is a colorless liquid. Okay, and nitric acid is a very strong arrhenius acid. It gives hydronium ion when dissolved in water. Okay, now we will see different type of reactions, and in nitric acid you will see some variety of reactions. Okay, nitric acid is a strong arrhenius acid. Okay, so obviously like other acids it will show properties of acidic properties. Okay, so it will react with metal. Okay, it will react with metal like copper, and these reactions are very, very important, I tell you. So, and first we will take dilute acid. Okay, here nitric acid is dilute, and what we get, the main thing you have to remember, I'll write down one more reaction. I'll write one more reaction which is a concentrated nitric acid. is concentrated. So when the nitric acid is concentrated, you get so basic difference between these two reactions, the basic difference between these two reactions is this. Okay, so all the other products are similar. So you have to remember that with dilute acid we get NO, and with concentrated acid we get NO2. Okay. Okay. Now we will see reaction with same reaction we will see with zinc. Okay, we will do it with zinc. So when zinc is taken, the thing that changes is this. N2O is formed, and zinc nitrate will be just like copper nitrate. We'll get 4 zinc nitrate, H2O instead of 4, and you get N2O. So this is the main difference between copper and zinc. With copper you get NO, and with zinc you get NO and 2O. Okay, and the concentrated acid, there is no difference in the reaction. You will get same product, just copper will change to zinc. So it's exactly the same reaction with concentrated acid. So the difference is with dilute acid. With dilute acid, copper forms NO and zinc forms N2O. Okay, so you have to remember just this thing. Okay, and these questions, देखो ये क्वेश्चन कैसे आते हैं, what happens when copper react with nitric acid. Okay, what happens when copper react with concentrated nitric acid or dilute nitric acid, इस तरीके से आएगा तो ये रिएक्शन लिखना होगा. ठीक है. Now concentrated nitric acid is also a very good oxidizing agent. Okay, very good oxidizing agent. So let's see some oxidizing behavior. Okay, and 10 HNO3. So balancing, you have to do the balancing. So mainly you have to remember that this NO2 and H2O will form. Okay, in all the cases you will get NO2. I'll write down other reactions. If you take sulfur, okay, so NO2 and H2O, they are fixed. Okay, it will give H2SO4. With phosphorus, again you will get NO2 and H2O plus H3PO4. Now balancing, you have to do the balancing thing. This is 4, this is 4, 2. In case of S8, it's 48 HNO3, 8 sulfuric acids, 48 NO2 and 16 water. Okay, in case of P4, you need 20 HNO3, it will give you 4H3PO4, 20 NO2 and 4H2. Okay, so the main thing is that this part remains the same. Balancing is different. Balancing तो आपको खुद करना है रिएक्शन को, ठीक है. तो ये पार्ट सेम रहेगा, सिर्फ ये पार्ट ही चेंज होगा. और सारे में क्या हुआ है, यहाँ पे आयोडीन जो है वो जीरो ऑक्सीडेशन स्टेट पे था, और जीरो ऑक्सीडेशन से यहाँ पे क्या चला गया, वो +5 पे चला गया है. यहाँ +4 पे गया जीरो से, यहाँ पे जीरो से कहाँ गया है, इसमें गया 6 पे, ठीक है. सो इस तरीके से आप चेक कर सकते हो. तो ये एक ऑक्सीडेशन हुआ है, ठीक है. Oxidation, so nitric acid behaves as a oxidizing agent. Brown ring test, very important reaction. Brown ring test or simply ring test. Ring test is a reaction used in chemistry laboratory, okay, to determine the presence of nitrate radical. Okay, this radical is detected by using brown ring test. And how this test is done, so NO3 negative from the salt solution, okay, and ferrous sulfate is taken, so you get Fe2 positive from ferrous sulfate, H plus from acid, so iron gets oxidized to, ferrous is oxidized to ferric, this is ferric, okay. And this NO, when reacts with this, forms a complex plus H2O. Okay, and this is brown. तो इस टेस्ट में क्या होता है, टेस्ट ट्यूब जो होता है, ऐसा टेस्ट ट्यूब है, इस टेस्ट ट्यूब में लिक्विड रहता है और एक बहुत सुंदर सा ऐसा ब्राउन रिंग प्रोड्यूस होता है, रिंग. दैट रिंग इज दिस पेंटा एक्ो नाइट्रोसो फेरिट, ओके, बाय आयरन. Okay, so this is brown ring test. This is one another chemical property of, this is one another property of nitric acid. Okay, so next we will study a few more things about group 15 elements. But before going to the further topics in group 15, we will conclude this video here, okay, because the part which is connected with nitrogen has been discussed. So we will start our fresh group study, okay. We will start with group 16, okay. We will start our study with group 16 in the next video lecture, okay. Thank you.